Okay, let's look at our expression for delta G now in terms of enthalpy and entropy. Now, depending on the temperature and the sign of delta H and delta S, we can have a spontaneous or non-spontaneous process. So let's consider possible signs for both of these. So say delta H is negative and delta S is positive. That means we have a negative number minus a positive number, so that's a negative and a negative. They will add to always give a negative number. So if delta H is exothermic, negative, and the entropy change is positive, then at all temperatures, then delta G will be spontaneous, negative. On the other hand, what if delta H is positive, delta S is positive, then I have a positive number minus a positive, so I have a positive and a negative. So it just depends upon the magnitude of delta H and T delta S. If delta H is greater in magnitude than T delta S, then delta G will be positive. So if delta H is greater than T delta S, then delta G is positive and it's not spontaneous. But if delta H is less than T delta S, then delta G is going to be negative because I have a positive and a larger negative number, and so it will turn out to be negative overall, and so delta G will be spontaneous. So the reaction will be spontaneous. Now, let's consider delta H being positive and delta S being negative. If that's the case, then we have a positive number minus a negative, so that's positive. So this is always positive now. Positive plus positive. So in that case, delta H will always be positive, not spontaneous. You can't change the temperature to make the reaction spontaneous. Then our last example, say if delta H is negative, delta S is negative. So now delta H is negative, but T delta S is negative, so we're subtracting a negative, so that will make this positive. So now we have a negative and a positive. And when we add those two together, it depends upon the relative magnitudes. So if delta H is greater than T delta S, delta G is negative, and if delta H is less than T delta S, then delta G is positive. So it's spontaneous in this case, not spontaneous in the other case. So the only thing we can vary here is the temperature. For a particular process, we have a specific delta H, specific delta S. We can change the temperature to change the relative magnitude of delta H and T delta S. So if we make temperature greater, T delta S becomes greater. If we make temperature smaller, T delta S becomes smaller in magnitude. So let's see how we can solve for a specific temperature that will make the reaction spontaneous. Say delta G is positive and I want it to go to negative. So I'm trying to find where it starts to become spontaneous. Well, it's going to go through zero. Going from positive to negative, it's going to go through zero. So if I find out where delta G is zero, then I know the temperature at which it will become spontaneous if I move just a little bit beyond the zero. So I'll set delta G equals 0, and I'll solve for temperature. So temperature is equal to delta H over delta S. So at this temperature, delta G becomes 0, so any temperature beyond that will make it become negative or spontaneous. So this is a way I can determine the temperature at which your reaction becomes spontaneous.